about arithmetic sequences and series. Keyword being arithmetic, and yes, it can be that easy as arithmetic, like you learned in elementary school. This is the beginning of chapter 10. I know we've been jumping all around, but this is 10.1. Arithmetic sequences and series. A sequence is just a math pattern, like 1, 3, 5, 7, 9. That's an arithmetic sequence. What are we adding every time? 2. And 2 would be your D value. That's what the D value is what you're adding each and every time. The first few problems are just this. A sequence is always written as A to the N. I don't know why they choose A, but they're basically saying you have a You have a sequence and N is your variable. Now you always start with 1 as your first term, and then you just go up from there. Every sequence, like the one I just said a second ago, 1, 3, 5, 7, 9. That's an arithmetic sequence where we're adding 2 every time. Now, what you have to remember is, in a sequence, I might say, here's a sequence. What is the 47th term? So, here's how you would write that on paper. This is the first term, second term, third term, fourth term, fifth term, and then so on. The formula to find any of those terms is called A sub n, because if you plug in this number for n, you will get that term. So like, for instance, on number 1, the first term of that arithmetic sequence would be if you plugged 1 into that. So if I plugged 1 into this, what would it give me? 5. What would my second term be? Yeah, would you plug it in? 8. What would my third term be? It's 11. 11. Plug in a 4, it'd be 14. Now you should notice, all the sequences today are going to be going up by the same amount all day. Up by 3, up by 3, up by 3, etc. Well, actually, I take that back. It looks like today we're just dealing with sequences in general. So they won't always be of that same flavor. But regardless, you just plug 1, starting with 1 and moving up. You plug those in for n, and those are going to give you the next entries in your sequence. So, for instance, on number 1, I didn't, but if I had said, what is the 13th term? So you'd be looking for A sub 13, 13th term. You just plug in 13. 3 times 13 is 39 plus 2. And the 13th term would be 41. So these A sub n's are just the formulas for finding the next whatever term that is. Number you plug in. I was incorrect in my intro in that these will just be arithmetic. They will not be today. Apparently we're doing arithmetic tomorrow. Today is just intros into sequences and series. One of the bad things about using the book. I get a little confused about where we are. This is leading up to the calculus. Yeah.
So, I still don't know what calculus is.
By definition?
No, by like everything.
By everything? I don't even know how to answer that. The definition of calculus? I'll tell you. According to Webster, the definition of calculus... What? No, it's not. It'll be in here. Calculus, by definition, is... Calculus. Any system of computation or analysis by a specialized algebraic function. Well, doesn't that help you?
No, because I had no idea what half the words you just said.
Do you know what algebra is?
Yes, I know what algebra is.
And how do you know?
I learned it.
Exactly. Well, when you learn calculus, you know what it is. Okay. So anyway, let's just jump down to number 5. First 4 terms of number 5. Now, if you were to just write this out, the first term would be negative 3 to the first. The second term would be negative 3 to the second. Third term would be negative 3 to the third. And then the fourth would be negative 3 to the fourth. And all I need from you is to tell me what those are. What is A sub 1? Negative 3. What is A sub 2? Negative 20. Just keep going. 81. That's right. Negative 3 to the fourth. 81. Right. So, they will alternate signs. Whenever you raise a negative to a power, you're going to be alternating signs, because anytime it has an even power, the negatives are going to cancel. It'll be positive. So just if you find yourself going negative, positive, you're not necessarily wrong. That's just might be what it wants. Number 7. Who can tell me what my first 4 terms would be on number... Actually, who can tell me what my first term would be on number 7?
Coach, over your head, so I can
Let's see. You're right. It would be -4. -1 to the first times 1 plus 3, and that would be -4. The second term on number 7 would be -1 squared times 2 plus 3. So that's +1 times 5. +5. Good. A long day.
I didn't realize that.
That's right. Well, and then you'll just keep... Easiest way to do it is just write it out, the little algebraic function. The third term, -1 to the third, and you can punch this stuff into the calculator if you're having a mental brain lapse day. So it's -1 times 6, but most of the time you should be able to see a pattern coming. Like on the top one, we're adding 3, so you can just skip the step and just start adding 3. This one, you see, oh, we're just raising the power that -3 is to, so you can just start writing that out. This one, the only thing that's changing, the only thing that will ever change, are your n values. So you can just start noticing to raise those numbers by 1 every time, etc., etc., etc. Is there another one on this page somebody would like to see the first 4 terms written out of? Or is it pretty self-explanatory about where these are coming from? Okay, moving on. Next slide. Did you want to see one? You sure? All right. Recursion formulas. Recursion formulas sound bad, but really they just have an n-1 in their formula. Now think about this. Let's think here, okay? Let's go back to this slide for a second. Let's look at that very top one we had right here, right? What was the third term? That was a sub 3, right? Here. A sub 3. Well, what would a sub 3 minus 1 be? What is that the same thing as? It's a sub 2. So a sub n minus 1 simply means you're going to use the previous term to plug into your formula. Let me show you an example. So like number 13. Now, the entire reason for this inequality is because on your first term, do you have a previous term to plug in? No, it's your first one. So they're saying for all values greater than 2, you're going to use this, or equal to 2. But for the first term, they're just going to give it to you. They give you the first term every time. So on number 13, a sub 1, 7. You don't have to do any thinking. It's just right there. A sub 2. So starting with the second term, I'm going to plug the previous term in here. So I take a sub n minus 1, which was what? 7. It basically says what was the previous term. 7 plus 5, and my new number is 12. For this one, I'll use the previous one. 12 plus 5. This is where you say the answer. Just the previous term. That's all a recursion is. It says plug in your previous answer everywhere you see a sub n minus 1. Yep. That's right. Let's just do 3. Use 3 first. Now you start plugging the previous term in for your a sub n minus 1. So 4 times your previous term would be 4 times your previous term would be, that's it. That's all recursion is. Let's do 17 together. Actually, no. I want you to try to write down the first 3 terms. Actually, it says 4. Write down the first 4 terms for number 17. I'll give you a hint, the first one's 4. First term is 4. Try to write down the first 4 terms on number 17. Done? I prefer you didn't, but it's okay. Well, you've already done it now. Thanks. Okay, here's work. Thank you. Luckily for you, we wasted so much time beginning the class, we were really just getting started. All right, who can tell me my second term? Before we go any further, raise your hand if you got something different than 11 you'd like for us to take a look at it. Good. We took 2 times the first term, so 2 times 4 plus 3. Excellent. What do we get for the next term? 25. Fourth term? 53. Excellent. Did anybody get something different that they would like for us, or have a question of any kind about anything on this page? Any questions about something you see up here? Great. Every time you see n minus 1, it just means use the previous term. That's all it means. Anytime you see a formula, because you're just going to be given formulas pretty much all day today. Anytime you see one with an n minus 1, that just means use the previous term. Now, you won't see one like this, but what if it said n minus 2? That means you used the second to the previous term. And n minus 3, the third. You know, just subtract from where you're currently at. All right. The general form of a sequence is given involving a factorial. Write the first 4 terms of each sequence. So we're just practicing with factorials now. A factorial, in case you've never experienced one before, a factorial, like for instance 5 factorial, is just 5 times 4 times 3 times 2 times 1. It's just that number times every number preceding it. It's also a button in your calculator, which you're more than welcome to use. But anyway, here we go. So, first 4 terms. So the first term would be 1 squared over 1 factorial, and then 2 squared over 2 factorial, 3 squared over 3 factorial, 4 squared over 4 factorial. That's going to be 1. I've written the exact numbers right here, but then I'm reducing them below. And the bottom line should be your finished product, first 4 terms, for number 19. Let me boot up the calculator. Nope, go away. The factorial button on your calculator, there it is. If you click math and scroll all the way over to probability, it is the 4th one down. So you can use it on your calculator in case you have to plug into big numbers later, and it will definitely save you some time than pushing everything in. For instance, if I asked you what 11 factorial is, rather than punch in 11 times 10 times 9 times 8 times 7 all the way down, just punch it in. 11 factorial. So 11 factorial, big number. Factorials add up quickly. Did somebody get something else for number 19 other than what we got on the bottom line? Or if you have a question about where those numbers came from?
So,
Braden.
how did you get rid of the exclamation points?
The exclamation points, factorials, are just math things. For instance, this is the same as 2 times 1. Let me change colors. This is the same as 3 times 2 times 1. This is the same as 4 times 3 times 2 times 1. That's all that they mean. You just start with that number and multiply by every number below it until you get to 1. Also, just a little tidbit, 0 factorial, in case you have to use it for whatever reason, is not 0, it is 1. Don't ask me why, because I don't even know. 0 factorial is 1. Of course, your calculator will tell you that too. So, yeah, it's weird. I guess I don't know. Anyway, well, 21. We don't have to write it out, but raise your hand if you have a question about how 21, where we would get those numbers from. You plug in 1 for the n, 2 for the n, 3 for the n. Excellent question. Excellent question. And let me think. You know, my instinct would be that it would work as normal multiplication, but let's see. Let's see. No, and here's why. Because let's say you had 2 times 6 factorial. 6 factorial is big, but then you double it. Okay, let me do something that I actually know. 4 factorial is 24, times 2 would be 48. But if you did 8 factorial, that's like in the thousands. So let's have our calculator answer that question for us, because I'm assuming it knows the order of operations better than I do. So I'm going to punch in there. 2 times 4 factorial. Let's see. Now, if it's only 68 or 48, we know you just do it straight across. No, you do the factorial first. And you do. Factorial trumps multiplication, the order of operations. Good job. Good question. So many people talking. Yes. What were you saying? What? What's PIMPDOS? Oh, that's the little acronym that you all were taught. Okay.
What were you taught?
I wasn't. Nope. I was taught parentheses and then exponents, and I was taught the fancy stuff you guys were taught. So, like for instance, let's just jump straight in. What would a sub 6 be? So that would be 2 times 7 factorial. You do your factorial first, then times 2. So blah blah blah. That's how you'll find. Yes. Yes. All right. Any questions from this slide? Marching on. All right. Now factorials are interesting because you can reduce them very simply. Let's look at 23. 17 factorial is 17 times 16 times 15 times 14 dot 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 all the way to times 2 and times 1. 15 factorial is 15 times 14 times 13 dot 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 times 2 times 1, right?
Didn't you just cancel?
Yes. Notice, everything cancels up to the lower factorial. So up to 15, everything cancels. So what's the only thing that's left? 17 times 16, which you can punch into your calculator and get. I don't know what it is. Yeah. Somebody. 272. That's an important thing to take away from today. We'll look at the next one too, but 27 will make a lot more sense if you can grasp on to the fact that when you have a factorial over a factorial, everything is going to reduce up until the lower factorial. And then the only thing that will remain are the numbers where the bigger one is higher than the lower one. So let's look at 25. So that's 16 times 15 dot 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 all over 2 times 1 times 14 times 13 dot dot dot. So who can tell me what all is going to cancel here? Everything to the right of 16 and 15, and then this portion, and what else? The 2 and the 1 don't, but does any pair of them, like, yeah, you could reduce this to like 8 and 1, so it would be 8 times 15 over 1. 120. So yeah, reducing radicals or factorials is much easier if you were to write it out. I think you would just need to put the entire denominator in parentheses. Other than that, I think you should be okay. Yeah, let's do it together. So that'd be 16 factorial divided by quantity. Yep. No other parentheses or anything is needed. Sure. Now, but this is the important thing to notice. Who can tell me what you think the answer to 27 is? You don't have to, I'll give you a hint. You don't have to plug anything in. How would that reduce? I'm sorry? The 2 is linked to the n via addition. So let's look at it like this. What if we were plugging in numbers for n? Like, let's say we plugged in 5 for n. Okay? So that'd be 7 factorial over 5 factorial, correct? I said if you plugged in 5 for n. You have to do order by parentheses first. So it'd be 7 factorial over 5 factorial, which reduced to what? 7 times 6, right? What if we plugged in 10 for n? That'd be 12 factorial over 10 factorial, so it'd be 12 and 11, right? What is the only thing coming out every time? Just the top 2 terms. Well, you could write that same thing in n format. Just like the recursion from the previous slide, how do I dictate the term right before it? N is our current term. What's the term right before it? N minus 1. So, if I'm at n plus, let me just start with the bottom. That'll be the easiest one. Wow, straight line. I'm going to do a big old fraction here. Straight. Okay, that's as straight as it's getting. So you have n factorial. So that's the same as n times the previous term, times the term before that, times the term before that, all the way down to times 1. Regardless of what n is, that's what it's going to be, right? You just keep subtracting. So we do the same thing with the top. We start with n plus 2. What's 1 below that? Well, that's just saying regardless of what n is. Let's say it was 50. We would do this, 50, 49, 48, 47, all the way down to 1, regardless. It'll always end in 1, a factorial. So what's 1 below n plus 2? N plus 1. What's 1 below that? Yeah, exactly. And then n minus 1, just like below. So what all cancels? Just n minus 1, dot, times 1. All that's going to cancel. And what are we left with? Well, sorry, I can't draw a straight line. What are we left with? N plus 2 times n plus 1, which you could FOIL. And this is the answer to this. Because the only thing that's left is your first 2 terms, n plus 2 and n plus 1. This is a very calculus topic right there. That kind of abstract thinking where you're not thinking so much about numbers, but you're doing math operations with concepts rather than actual numbers like above. Raise your hand if you would like to see another example of this kind of reduction. Okay, let's do it. How about this one? What if I had n plus 3 factorial over, I'll stick with these for now, n plus 1 factorial. What's the difference in those two? What is in the top one that's not in the bottom one? And? That's right. The only thing that's in the top one and not the bottom is n plus 3 and n plus 2. So you'd FOIL that, and that would be your answer. Or even if this was like n minus 1, it's a little more complicated to think about, but basically you just go down in this one until you hit this. So that'd be n plus 1, n, but then n minus 1 is here, so everything there would cancel, so this would be what you're left with. Well, you won't have one that's that long. Actually, you would, but I don't think you'll have one like that. I was just speaking theoretically. If it was just in on this one, then you wouldn't need the n here because that would cancel, and that's what your thing would be. Yeah. Raise your hand if you'd like, if you have a question about this, or if I can elaborate on this in a different way that might help you. Chris, head up, buddy. Anybody? Okay. Moving on, only 2 more slides. All right, these little sigma thingies are called summations. They are summations. They are nothing more than arithmetic sequences, but they're shorthanded. Rather than writing a sub n equals, there's a shorthand for it. This one says, here's your equation, but instead of n, they gave you I, and they're saying, we want you to go from 1 to 6. The number below the sigma is where you start. The number above it is where you finish. So, the answer to 29, find the sum. That'd be 5 times 1 plus 5 times 2. 5 times 3. I don't know. Have you? 5 times 4. 5 times 5. Whoa, excuse me. Plus 5 times 6. Yep. Now, if you notice, none of these are more than 5 steps. So they tried to, except for that one. So they tried to, keep the numbers you're having to add together small. So, but does what we're doing, does where those numbers that I've written in blue, is there a question about where I'm getting those? Oh, excellent. Thank you. There's a way to check that on the calculator. But before I show you how to do it in the calculator, which you're all welcome to do, I want to make sure that you know where the calculator is getting its numbers. Okay, is there a, let's see. So, like 35, that'd be negative 1/2 to the first.
Oh, no, we didn't multiply it times 5 at the end.
No, you multiplied every step by 5. 5 times 1, 5, yeah. Times squared. You don't have to write this down, I'm just writing you. And then where would I stop? Yeah, at the fourth. And then you'd add those together. Good. Before I show you how to do it in the calculator, look at any of them on that board right there. And is there a question about how you'd write down any of them? Yeah, good question. Is there a variable in 37? No. So there's nothing to plug your numbers into. So how many steps is this? 5, 6, 7, 8, 9. Just 5 times, you just need to add 11. It seems stupid, but yeah. There's no variable. You can't plug anything in anywhere. Yeah, so it would be 55. 5, 6. You have to actually start with the first term. Yeah. If you want to subtract, always remember you'll be subtracting and then plus 1. That'll be how many terms there are. So like this one, 6 minus 1 plus 1. There's 6 terms, 4 terms, 5 terms. Whenever it starts with 1, the top number is the number of terms. But sometimes it doesn't. Like that one. Good question. 39. Let me erase this. 39 would be negative 1. Let's see, we're starting with the 0, right? To the 0 over 0 factorial plus negative 1 to the first over 1 factorial, and then all the way up to 4. But what is 0 factorial? There you go. That's right. But you're right, 0 couldn't be by itself. So that's how you'd write it out. And there will be a test question that says, here's a summation, or write out the terms so it wants you to know. So this is what I would need to see, not even the answer, but the actual right there. And it'd be multiple choice anyway, so you just have to see which one it was. Now to plug it in the calculator, I don't do this very often. Hopefully I can remember how to do it. Here's how you plug it into the calculator. If you all want to have your calculators out, it'd be much easier if you just follow me along. Let me find everything. List. Uno momento. There it is. Okay. Hit second stat. Second stat. It'll take you to this screen. L1 through L6. Over here. Second stat. Now scroll over to operations and scroll down to, oh, I'm sorry, go one more. Go over to math and scroll down to sum. That's what we're doing. These are called summations, and this is a sum. So we are going to sum. Enter. Now, we need to tell the calculator that we wanted to add together an entire sequence. So go right back to where we were, second stat, and go over to operations, and pick sequence, the fifth one down. Sum sequence. So you should be looking at this on your screen right now. Raise your hand if you're having trouble finding these buttons. Oh, excellent. Alright, so let's pick one of the trickier looking ones. How about this one? We'll work on number 39. So first thing we're going to do is put in our equation. So, what was it? It was negative 1. Now, watch out for your parentheses. So I'm just going to put lots of parentheses in there. I can always delete them later. Negative 1 raised to the x power. I know it said I, but it doesn't really matter. Just a variable. That's all in the numerator. Divided by, what was it, x factorial? You know what? I'm going to make sure that that whole denominator's in parentheses too. There we go. So, negative 1 to the x divided by x factorial. Now, first thing you have to tell your calculator wants to know 4 things. It wants to know what are you using for your variable, as if it couldn't figure it out. So, you do comma x every time. That's our variable, and it'll always be that. Next thing it wants to know, what number are we starting at? What number are we starting at for number 39? 0. Yeah, that's the number at the bottom. Oh, comma's right next to parentheses. And right to the right of x squared, and right above 7. I gave you all 4. No? Okay. Oh, well, it wants to know 4 things. It wants to know what's your variable, where are you starting, where are you ending, so guess what's next going to be? 4. And then the last thing is kind of stupid. It wants to know, well, actually, it's not stupid. It says, how big are your steps? In other words, if we could put like 0.1 in there, and it would add everything from 0, 0.1, 0.2, 0.3, 0.4, all the way up to 4. But we are always just going to do whole steps. You're always going to do comma 1. So you should always start with comma x, and then comma 1 at the end. And the only thing that's going to change is your range. Then you hit enter, and it adds it for you. So that would be 3/8. Math enter, enter, gives you a fraction.
So I'll just put those numbers in the next.
It'll always be x, because that's the variable you're just going to use when you plug in your formula. These are your starting point and your ending point. And then you'll always choose 1, because you have to tell it the step size. The 1 is the most frequently messed up part when people punch this into the calculator. You'll always forget the 1. Oh, I just had it give it to me as a fraction. You could write 0.375. Shows the fraction. Does anyone want to see me do that one more time? It says find the sum. You can add it yourself, sure, or you can do. I don't care. I actually want the number you get when you're done today, but I don't care how you get it. Anybody want to see that again? Okay, lively bunch. I get it. Okay, last thing, and there's no good way to do these. You just have to use some cleverness, some savvy. So I'll show you one of them, and then you're just going to figure them out when you're doing it. These basically say, here's a pattern with a starting point and an ending point. What was the formula to get this pattern? So like, for instance, 43, well, it wants you to use 1 as the lower limit, so you're always going to use I equals 1 today. Now you don't know your upper limit yet. Now look at 43. Is there anything that's not changing the whole time? The squared. And that's not going to change in your formula either. Now, how could we plug in 1 here to get our first term? What did we do to the 1? Yeah, we just squared it, right? Your formula here is just going to be I squared, because 1 squared, 2 squared, 3 squared, and how high did we go? Yeah. And that's all you have to do for these. Just some of them are a little harder to visualize. So that would be the answer to 43. Yep. And not all of them will be quite this simple. 49, okay. So, we know we're starting with 1. Now, you want to do the numerator or denominator first? I would do the numerator. Let's see. Now, if you know that you're starting with 1 and then going 2, 3, 4, 5, 6, what is the numerator doing with our pattern? Well, yeah, the summation already does the plus 1 for you, but isn't it kind of the exact same as the entry number every time? So it's just I. And in fact, that'll be a big hint to what 47 would be, but the top is just whatever your entry is. 1, and then 2, and then 3, and then 4. What is the bottom? Who can tell me what the bottom would be? I plus 1. Very good. It's just 1 greater than the top. And how high are we going? There you go. And that would be 49. Muchos goodos. It tells us to in the directions. Yeah, actually, there's infinitely many ways to write any summation, because you can start and end with any terms you want. But they tell us to start with 1. Yes, ma'am. They wanted you to notice that the +1 was key, I think. That was kind of a hint. But yeah, 14 over 15 would have been.
So why is it I?
Y is our what? You'll always start with 1. It'll always be I equals whatever number you're starting with, and they tell us to start with 1. So. On 51, well, let's see. I equals 1. Is it just, well, it would be in, or I. We're using I. It would be I if it was just 1, 2, 3, 4. But is there anything just not changing about the numerator? The 4. Now, what's being done to the 4? It's being raised to what? Nice. I. 4 to the first, 4 to the second, 4 to the third, whatever our I value was. Got it. And how high do we go? Oh, yeah. You're just going to go to n. Whenever it doesn't have a number at the end, that's a tricky one right there. You'll just end at n. There's no like formula or perfect method for doing that. You just got to try a few things. You might be wrong a few times. You might think it's I over I squared, and you try a few terms and it doesn't work out. Best thing to do is come up with one and then plug in 1, 2, 3, 4 and see if it matches up for all your terms. And if it doesn't, you got to change it. You got to tweak it. All right, here's your assignment.